Okay, Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. In this video, we are going to conduct experiment 6, which is on motors and generators, especially DC motors and DC generators. And before we start, please make sure that you have a copy of the manual with you, and also a pen to write the data that we are going to gather from this experiment. Okay, before we conduct the experiment, let me walk you through the equipment that we use in this experiment. And as you can see in this picture here, this is the whole setup for the experiment. Okay, the device that we are testing is a DC generator. So as you can see, it's located at the bottom on the right hand side. This orange item here, this is the DC generator that we are going to do the test on. Okay, and then on the left hand side at the top, we've got the 3-phase AC power supply that will supply the AC voltage to this AC motor here. Yeah. Okay, and why do we need this AC motor to conduct the experiment? Because as we should know that in order for a DC generator to work, it needs a prime mover, the source of the mechanical energy. So the AC motor will supply the motion to the DC generator. And we've got this coupling which couples together the AC motor and the DC generator. Yeah? So when the AC motor starts to rotate, the DC generator will rotate as well. Yeah? So they will, both of these machines will always have the same speed. Okay, and then attached to this AC motor, we've got this brake system. It's a control unit. The function is to allow us to control the load to the AC motor. By doing so, we can then basically run the motor in two different modes, yeah? Either a speed control mode or torque control mode. Okay, and then we've got this field of variable field resistor, yeah, which is connected to the field circuit in the DC generator. Then we've got this load resistor, which is connected to the output of the DC generator. And then finally, we've got these 3 multimeters. Yeah, the first one here on the left-hand side in the middle. I mean, in the picture is shown in the middle. Is to measure the armature current, and then next to it is for measuring the exciter current. Yeah, or also called as excitation. Also called as a field current. Yeah? And then finally we've got this one on the right hand side, which we are going to use to measure the output of the generator, which is the generator voltage, or VG. The multimeter on the left hand side is not actually part of the experiment. Okay, now we are going to follow the procedures that is stated in the section 4 in the manual. First it says that connect the circuit diagram shown in figure 11A and figure 11B. So actually the system has been connected, just like what is shown in those two figures. Then step 2, connect the 3-phase asynchronous motor shown in figure 1.2. Okay. Step 2, connect the 3-phase asynchronous motor, which is this motor here, as shown in figure 1.2. So all the connection has been set up for us, and then this motor is connected to the 3-phase supply. and also the controller. Then step 3, couple the generator to the 3-phase asynchronous motor. This is again the generator, and here is our 3-phase motor. So this motor will be used as the prime mover of this generator, and they are already coupled. This is the coupling, connecting the shafts of the two machines together. Okay, step 4, set the range of the control unit, which is already done. Here, if you can see, the range of the torque is up to 1 Nm, and the scale is reading this as the reading for the speed. It's multiplied by 1000, so the unit of this reading is 1000 revolution per minute, or 1000 RPM. Okay, step 5, set the field generator to 0. And here the field generator is already set to 0. And then the load resistance to the maximum. This is load resistance, and we have put it in the maximum, approximately 1000 ohms. Okay, and then step 6, operate the generator. So I will switch this on. So now you can hear that the motor is running, it's making all this noise, and it's driving the generator as they are connected together with by the coupling. Okay, next, adjust the load resistance to the drive machine to obtain 2500 RPM, or maximum RPM that can be obtained. So again, you can see the speed from the scale here, and it already says it's about 2550. So we want to adjust the load resistance until we get to 2500 on the figure here. Okay, now I'm adjusting the load resistor until I get to 2500 RPM. Okay, it's 2500 RPM. Now we can check all the readings. Again, this is the armature current, IA, the exciter current, IE, and this is the output voltage of the generator. The notation is VG. Okay, now I'm going to adjust the resistor, the load resistance to 3500. If I go too fast, you can pause the video to get all the readings. Okay, that's 2500. So 2400 RPM. You check the reading. Now I'm going to go to 2300. That's 2300. That's 2200. 2100, 2000, 1900, 1800, 'Close to 1700. I think that's the lowest that we can go, so we can skip 1600 and 1500 RPM. Okay, so this experiment is done, and then you can look at the data, analyze the data, and answer the questions that have been given in the manual.